Okay, we're going to do this a little bit differently than what you're probably used to in other classes. Rather than having a static slideshow, what I'm going to do is I'm going to be converting this to a video. The video is going to be able to be paused, so you should be able to pause that and take notes and do what you need to do to understand the material. So with that, let's take a look at crime scene sketching and mapping. Okay. In this particular chapter, there's a number of objectives we're going to cover. Number one, we're going to identify why we're doing a crime scene sketch. We're going to identify the 5 essential elements of the crime scene sketch. We'll identify and explain the difference between the 3 views used in the crime scene sketch and why they're used. We'll also identify the basic methods of mapping the scene and explain their strengths and weaknesses. Now, crime scene sketching comes under the documentation phase of Garner's crime scene processing activities. After you've already conducted your scene assessment and you've observed all the evidence in the scene as it sits, you're going to document this scene. After taking your notes and taking your photographs, you're then going to be doing your sketches. And as you're going to see, we do it in this order because some of the activities involved in sketching are going to be by their very nature obtrusive and potentially destructive. Now, what is crime scene sketching and mapping? What you're doing is you're creating a map or a two-dimensional view of the scene and all the important evidence and artifacts that are found inside. Now, as we talked about, this is particularly intrusive. During the measuring and recording process, you may end up inadvertently moving evidence. So this is why you want to have photographs done before you do anything else, because the photographs will capture the scene exactly the way you found it. Now, while you can certainly sketch without mapping, you can't necessarily map without sketching. Now, the idea behind this is with that sketch and your photographs, you should be able to recreate the entire crime scene as it happened inside of an empty warehouse. And at some point, especially with a cold case, a crime scene reconstructionist will have to do just that. Now, the crime scene sketch illustrates the layout, orientation, and interrelationships of the scene and the evidence. In other words, where is everything laid out? Where are items pointing and so forth? And this information may be useful to a reconstructionist at some point. Now, most crime scene sketches are done as a bird's eye view. In other words, as if you were a bird flying overhead. Now, it may be printed and done to scale, or it could be just a rough hand sketch. In any event, you need to represent what that sketch is, and we'll talk about that when we look at the components of a crime scene sketch. Now, there's 5 essential elements included on a crime scene sketch, and they are a heading, which is a title that explains what the sketch is all about, a diagram area where the actual sketch is, a legend indicating what the symbols represent in the sketch. There's also a title block, which contains administrative data such as a case number, address, and so forth. In pre-printed forms like you'll find on imprimis.net, those title blocks will be pre-done for you, and all you'll need to do is to fill in the blanks. Finally, there are scale and direction notations. For scale, it could be notations such as 1 inch equals 6 inches. Or it may not be to scale, and if so, you're going to have to indicate on that sketch not to scale. I would pay particular attention to these essential elements that we've just described because they will more than likely appear as test questions in the not too distant future. Now, there are some variations in the sketch view. As we mentioned before, the one that's commonly used is a bird's eye view. In other words, items on a horizontal surface. There are other views such as a cross projection and an elevation sketch, and those are used when we're trying to get different dimensions. and we'll talk about those in just a moment. And this is your typical bird's eye view sketch. This particular sketch, as you imagine, has been done with a computer-assisted drafting program. Everything is in a horizontal plane, such as furniture, evidence, body position, and so forth. And this is another example of a crime scene sketch. This is kind of a rough sketch that was done in the field, but it looks like there's some annotation that was included after the fact. This one has all the particular elements that you're looking for in a sketch. You have your diagram area where the sketch actually is. You have a direction indicator, the north-seeking arrow. You have the notation, not the scale. You also have a legend and a title block. But if you look at it, there's one element missing. Can you determine what that particular element is? Time's up. What is that element? An elevation sketch drawing is done in a side view, and this is where you're going to show, for example, a wall. And as you notice, this particular elevation sketch memorializes bloodstain patterns on a wall and window. A bloodstain pattern interpreter might, or a bloodstain pattern examiner may need that sort of sketch so they can recreate or make a determination regarding the bloodletting event. Cross projection sketch combines both the bird's eye and the elevation sketch. In other words, what it looks like is the walls have been laid down, and this allows representation of evidence found in both the vertical and the horizontal planes. In this particular example, you see the window at the upper corner, and there's 2 bullet holes in it. This may be necessary for a shooting reconstructionist to determine what happened during this incident. Additionally, there are 3-dimensional sketches. These sketches are usually done with some sort of software, and oftentimes with some form of computer-assisted technology, such as a total station. Total stations are computerized scanning systems that allow you to place a computer-assisted scanner in a room, or for that matter in an outside scene, and the scanner will plot every single point in that room with accuracy that is probably unmatched anywhere else. There's just one problem with those. The total station is not going to pick up on any item that's underneath a chair or table, because typically the laser scanner will stop at the table. Now, this is kind of an advanced representation that we're going to make you aware of, but we're not going to be teaching it in the lower division curriculum. And this is an example of a finished product from a 3-dimensional view. You have a photograph and you have a 3-dimensional sketch that was created with the use of a total station and a computer-assisted or CAD drawing program. Now let's look at some crime scene mapping techniques that are basic and that every crime scene or incident investigator should know. The most common are going to be baseline and rectangular coordinates, triangulation, polar coordinates, triangular or rectangular coordinates on a grid, and triangulation on a baseline. We're going to talk about each of these methods in turn and describe some situations where these can be utilized. Baseline mapping is often used in exterior scenes with limited landmarks. how you would perform a baseline mapping is that you would take a datum point that you can recreate and you extend it either due north, south, east, or west in a given direction. A single measurement is made from the evidence to the baseline at a right angle. So while your baseline is extended, you then make additional measurements from that baseline. And for most interior scenes, you wouldn't want to use it. Now, the last time I used baseline mapping, it involved a traffic homicide where a datum point was created using a telephone pole that has an individualized serial number. A baseline was extended due south from that point, and evidence was measured from as distances from the baseline. Rectangular coordinate mapping is best used in an interior crime scene with a clear boundary, such as a wall and a wall corner. Two measurements are made from the evidence to the surrounding walls at right angles, and it's not nearly as precise as triangulation, since the measurements are generally from the center of mass. There are some evidence that it may be useful for it, but not all, and we'll discuss that momentarily. For example, we have this picture of a sexual assault where you have a victim, you have a pile of dirty clothing, and you have a firearm. In this case, you have two measurements taken from the center of mass to the item, or to the mass of dirty clothing, and then it goes to the wall at right angles. It only requires two measurements. However, this is not particularly the best method for other items, such as this handgun here at the lower corner. The problem with measuring the handgun using rectangular coordinates is if you're measuring from center mass of the handgun, or in this case what appears to be the trigger guard, that weapon can be rotated in a 360-degree direction, and that could have a great impact as to whether or not there's a proper reconstruction. And it can also allow a great deal of reasonable doubt for the defense attorney to utilize in court. So I wouldn't recommend this for items that are regularly shaped, and we'll talk about that in just a minute. Triangulation mapping is best used in scenes with landmarks that are very evident. Interiors, for example, are a good place to use it. And it'll fix the object in a specific position. It does take a little more time, but it's worth it to accurately place an item in the crime scene. And the number of measurements you may have to take are based upon whether or not the object shaped is regular or irregular. Now, let's talk about regular shaped objects. Regular shaped objects are items that have a fixed shape and they don't change with movement. When measuring a regularly shaped object, you need a total of 4 straight line measurements from 2 distinct landmarks in the room to 2 distinct points on the item. Now, we're going to talk about some regularly shaped objects that don't fit this criteria in just a minute. And again, this will fix the item in a very specific position in the scene. Now, with the irregularly shaped items, these are shapes that may move when they're, or I'm sorry, where the shapes will change when the item is moved. And these are things such as blood pools, piles of clothing, any pool liquid, and so forth. But it should also include items that don't have a definitive point, such as beer bottles, liquor bottles, beer cans, and so forth. Because there is no distinct point, you'll have to measure those as if they were an irregularly shaped object. And this will fix the item as effectively as is possible. Remember, there are certain limitations that are inherent to any irregularly shaped item. And that's because they don't have a defined point. You can't fix it in a room. Now here's an example of triangulation mapping. Now if you'll notice, the pistol is mapped precisely in the room. The muzzle of the pistol is precisely mapped to points in the room, as is the butt of the handgun. And this can be a very relevant point if you're attempting a reconstruction based upon events that have been suggested by a witness. The pile of dirty laundry in the center of the room is also mapped from the center mass to 2 points in the room. Now, as I mentioned before, you may have to use center mass measurements on beverage containers. Now, the next type of mapping is polar coordinate mapping. These are usually used in open fields, exteriors, and so forth, where evidence is scattered, such as improvised explosive device explosions, bombing incidents, and plane crashes. In all these incidents, you have items that are scattered over a wide area because you have a great deal of force that is imparted upon an object, and things are blown all over the place. This is going to require some special equipment, but not as expensive as you might think. You can often do an effective job of polar coordinate mapping with something as simple as a $10 compass. And we'll talk about that in the laboratory session that follows. Naturally, if your agency has more funding, you might be using a laser transit or sighting transit, and these will provide you with a little more peace of mind, or it may provide you with a little more accuracy. Now, coordinate mapping is done by taking measurement and an angle from a datum point, and we'll talk about that again in the laboratory session that follows. If your agency doesn't have the money for a transit, this can usually be accomplished using a military Lensatic compass or the Meridian compass that you see on the right hand side of the screen. In testing, we found that the Meridian compass does a much better job, and the Meridian style compass is readily available for less than $10 at a lot of different outlets. However, there may be some Lensatic compasses that were acquired as part of a military cooperation program, and those are also useful as well. Now, to conduct polar coordinate mapping, you take a datum point. It's memorialized and a GPS coordinate is obtained, and then you measure an angle between the datum point and the evidence itself. Then you take a horizontal measurement using either a measuring tape or a traffic laser device. Again, this is a method that is practiced more with some of the upper division classes, but we'll have a brief introduction to it in this class. Then we have rectangular coordinates on a grid. This particular method is particularly useful when you're investigating clandestine graves and war crime and mass graves. What happens is the first thing you have to do is establish a grid and a square. And we'll talk about that in just a moment. When establishing the grid, the first thing you have to do is establish a datum point. And again, the datum point could be triangulated, or you could use a GPS and a section of steel reinforcing rod. But whatever method you use, it has to be something that you can recreate fairly readily, because everything has to be reproducible. This is part of the scientific method. Having said that, Once you establish your datum point, you then establish your X and Y axes, going from usually from east to north. Once your datum is set up and your baseline is extended to the right and up or east and north, you verify that these two sides are at right angles using what Garner likes to call the 3-4-5 rule. And this is what the 3-4-5 rule is all about. Once you extend your X and Y axis, you then measure 4 units out and 3 units up. Once you've taken those measurements, your hypotenuse or long side of that triangle should be 5 units. If it isn't, you may have to adjust your X and Y coordinates. Or I'm sorry, your X and Y axes. Well, this does have its origins in geometry, should you ever be questioned about it. What that means is that you have a right angle when a 3 unit by 4 unit triangle has a 5 unit hypotenuse. Once the grid has been laid out and everything is squared, you can then use rectangular coordinates to precisely map out the location of bodies and other evidence. In this case, rectangular coordinates are being used to map out the right heel and the top of the head of this particular victim. With triangulation on a grid, you can use the same right angles on the grid for triangulating the distance between the right heel and the right hand, and fix the location of this particular body inside an investigated grave site. Again, as you may have noticed in Professor Costa's class, a grid was established using string, and that sort of grid is commonly used in archaeology and in clandestine grave excavations. Triangulation on a baseline is also useful, again on an exterior scene where a field of evidence is not too widely scattered. Again, you'll have to create some reference points and a baseline. I've found that this particular method works well if you're investigating a traffic homicide on an interstate freeway or toll route, because you have a conveniently located baseline in both of those areas. Can anybody think of what that baseline could be? Time's up. How about the guardrail? Here's an example of triangulation on a baseline. You've established your datum point. Now, guardrail posts are not serialized like you'll find with utility posts, but you may have to triangulate them using other things such as a survey mark, which are all recorded and serialized, and a light pole. Failing that, you may have to use GPS coordinates. And then you could utilize, for example, the guardrail as your baseline, and then measure points along that guardrail to your evidence. And then your end baseline would be indicated, for example, by 2 trees or GPS coordinates or some other method. Again, as I mentioned before, this method is useful if you are conducting a traffic homicide investigation on a freeway or on a toll route. Now this concludes our presentation regarding crime scene mapping and sketching. Now if you have further questions, Garner Chapter 7 is a good resource to have. Also, the Law Enforcement Investigations Manual that you should have downloaded in week 2 has a number of good resources in Chapter 4 on conducting sketches. And finally, you can message your instructor with additional questions either through Blackboard or by email at tseguin@kaiseruniversity.edu.